Okay, session is being recorded. It's 9/12, October 22nd, Thursday, and we're going to do a walkthrough of this lab number 2.7.2 on the real actual equipment. Packet tracer is real close to it. Packet tracer doesn't do everything real equipment does, but it's about 95% accurate. I'd like to use the real equipment to do this. Now, your machine you're sitting at is connected to S1 and S2. This machine here will be R1 and R2. I only have one machine. I have to swing cable. So right now I'm connected to the two routers. We're going to check and make sure that they're erased. The top screen, I was connected to the switch. I just wanted to make sure the switch had no configuration. So it has no VLAN.dat file. It has no startup configuration. Don't start, not present. And then I swung the wire over to the router. I did the same thing on the bottom. The lab goes and does the setup of the routers first, and then we'll swing the wires over to the switches. Since you're sitting in the classroom, all you have to do is move over to this keyboard, and you'll see R1 and R2. And where you're sitting at now will be S1 and S2 using the Terra program. Okay, so I'm going to go ahead and do this run through here, and then if you have any problems with connecting, I'll help you, the people that are here actually in the lab. Okay, so the top screen, I've connected to a router now. It says switch, but I was connected to a switch. Default host name of switch is switch. Default host name of router is router. So I'll press the enter key a couple times. I'll say no. I'll do the same thing for the bottom because it takes it a second to process it. And he gives us a setup routine here on page 2 of the lab. And I'll start with that. Okay, so he's screening all the stuff he knows. It's like the Linux booting up. A bunch of stuff comes up on the screen here as he initializes the operating system. Okay, so it's router. The top screen is connected to what's going to be my R1. The bottom screen is connected to what's going to be my R2. Okay, so they're already cabled up. I cabled them up for you because I'm going to not allow you guys to get your grubby, grimy germs on all the wires. I'm going to do it myself. You guys get to use your private workstations and you're socially distanced from everybody else. Okay, so on page 2, I'm going to go ahead and do the first step 1 has been done. I've done the cabling for you. Step 2, we're going to assign a device name to each router. And there's most of the questions are fulfilled, are printed in this version of the lab. A few, you have to fill out the answer. This is one of them. What's the command to use the host name, to give it a host name? Bueller, anyone? 54321, thank you for playing. That's a nice party gift for you. So first of all, we're going to go to the privileged exec mode. No passwords have been set yet, so I just tapped enable. And I'll go to the global configuration mode, config T, and then the command is host name. And it's supposed to be R1. The prompt immediately changes to R1. I'll do the same thing on the second router. Enable, configure terminal, host name, R2. Okay, so we set the host names. The next thing he's instructing us to do is step 2B is to disable DNS lookup. So this is so if you accidentally type a command and you misspell it, it won't hang you up for a minute. So no IP domain lookup. And I'll repeat that on the first router. No IP domain lookup. Have you got your Terra terms going? Okay, drag it down a little bit, and I'll show you how to get the second one. You maximized it. Yeah, you really maximized it. Just drag it down a little bit. How about that? Okay. Click Terra term again. Material. Use COM4. Let's COM4. And so that's your COM4 is your R2. COM1 is your R1. You're hardwired. Okay, I'm on step 2, little letter C. We're going to do the enable secret class command. Put the password in there. Enable secret class. And do that on both machines. Okay, now we're going to set the console password. Line console 0 password Cisco and log in. Find console 0, password Cisco, log in. So I'm going to illustrate on this top router here. I'll log that. I'm going to log back in, and he's going to, now he's asking me for the password Cisco. Now I want to go to the privilege exec mode, the passwords class. So that's the code pair we always use in our Cisco laboratory classes is Cisco in class, so that you can always get back in a switch or router if the last guy forgot to do it for you. Okay, so we set our passwords. The VTY passwords is when you telnet in. I'm going to skip that in the interest of time today. And I'm going to do the command service password encryption because when I do a show run, you can see that the enable secret password is encrypted. But password for the console is shown in plain text. That's not very good. So we want to put in the command here that's on the top of page 3, service password encryption. That'll fix that. I have to be in accounting mode for that. Service password encryption. Now I'm going to show the command, and you can see the difference. Now instead of saying password Cisco, it says password has the number 7. That's a weak encryption. That is not as strong as enable secret class. Enable secret class is MD5. It's very difficult to decipher. This is weak, but at least it doesn't show on the screen. Okay, now banner message of the day. I'll go back to the configuration mode. And banner message of the day is a thing that we can put on the screen that'll show whenever someone tries to log on, they can get whatever the lawyers company you work for, the lawyers will tell you what to put there. They used to say, welcome to the UTA Computing Center. And then the hackers broke in and the judge put them out free because we said, welcome. Well, now we can't say welcome anymore. We must be nasty. So we're going to say, get out of here, you, or something like this. I like to do warning, Bill Robinson from the Lost in Space thing. So here's what happens here. I'm going to log out of the machine again. Log back in. Before I even get a chance to put in my password, I have gotten the legal warning. Message of the day, banner warning message of the day. Okay, so let's go. Enable class. Now we're going to save these configurations that we've done so far with copy run start. I'm using the Gonzo secret insider command, which is write, short for write mem. And I'm going to swing my cables over and we're going to do the switches. And then we'll go back to the routers and we'll do the OSPF step. You guys in the lab, you just swing your chair over from your workstation you logged into to the chair place with the X in it, and you'll be working. We'll work on the switch where you're sitting at, and the X one is the one with the routers. Okay, I should be at default switches. Switch. Okay, how do we check to make sure the switch has no configuration on it? I'll run through it and check here just to make sure. I'm going to go to the privilege exec mode. It didn't ask me for password. Show me the startup configuration on this switch. There is none. Another thing you must check on switches is do show flash or dir and make sure there's no file there labeled vlan.dat. Otherwise, you could pre-existing configurations with the VLANs could mess up your configuration. Okay, so this switch looks clean, and I'll go ahead and give them a host name. So I'll go to the configuration mode, host name, switch 1. Do the same thing for the second one. Let's go to the privilege exec mode, do a show startup configuration. There's none. Check a dir, there's no VLAN file, so I can go ahead and start using this switch. Host name, switch 2. Okay. In this lab, the switches are acting, there's going to be no VLANs, there's going to be no IP management addresses on the switches. They're acting like a pass-through connection. You could replace these two switches with an Ethernet cable and the lab would work great just the same. So I'm not going to do the rest of this configuring of the switches here in the recorded presentation. I'm just going to go ahead and skip through and let's get to the good part and get to the routers and configure them. Oh, before I do that, we've configured the host name on the two switches, S1 and S2. We've configured the host names in the router, R1 and R2. I like to always do this first, and then, I haven't done the no shutdown command on the router yet, so I won't be able to show you this. If I do a show CDP neighbor, all he's going to see is the other switch. I haven't done the no shutdown command on the router port yet. I'll do it on the router, and then I'll illustrate it. Okay, I have to swing the wires back now, the switches. Okay, I'm connected to the router. I did do the host name on it, but I didn't do any. If I do a show IP interface brief, all the interface ports are shut down by default. We're going to be using the port G0. Oh, I got you. In the lab here, in the physical lab here at the campus. This says G0/0/1. On our routers, it's G0/1. It's 1 less 0. If you do it on packet tracer, you can choose the 4321 model router, and the interface number will match up perfectly with this lab. So show IP interface brief is a real cool command because you can go to a router or device and you're not sure what the interface port numbering scheme is, and type show IP interface brief, and it'll show you all the port numbering on this particular one. So whenever here in the lab it says G001, we're going to substitute G01 because I try to type G001, it won't take it. Okay, I want to go to the configuration mode, and I want to turn on that port. So I'm going to say interface gigabit 0/, I'm going to type 0/0/1 to show you what would happen. It goes, what? I don't know about G001. I only have 0/1. I'll just say 0/1. And it takes that, and I'll do no shutdown. That's all it takes for Cisco Discovery Protocol to come into play. So now I should be able to type show CDP neighbor. I can see my neighbor's S1. R1's neighbor is S1. So the wiring must be good. I did the wiring. It's my fault if the wiring didn't work out. Okay, so I'm in the sort of the top third of page 4 under part 2. We're going to configure IP addresses and do some OSPF configuration on each of these routers. And we're starting with R1. I'm at R1. Let me see. R2 is at the bottom. We'll do that in a minute. Okay, so I'm going to go to the global configuration mode and go to interface gigabit 0/1. And let's actually give them the IP address that's on the front page of the lab. IP address 10.53.0.1 and a standard /24. I fat fingered it. 10.53.0.1. 5.255.0. Okay. Now, on a step it says no, what? And there's something for you to fill out on your answer sheet. What did we do to activate the port? No shutdown. Thank you. I did it earlier just to make CDP work. If you don't type no shutdown, it won't come up. Now we're going to type exit, and we're going to create a loopback port. A loopback port we're using in this lab instead of using our virtual PCs. So I'm going to say interface loopback. He says one. It doesn't really matter what number you use. You have 65,000 of them. I'll do what he said. And we're going to give him an IP address, just something that we can ping later too. And check the OSPF routing. 172.16.1.1 and a /24. Now, loopback ports do not need to do the no shutdown command on them because loopback ports are born alive. They're like the tribbles on Star Trek. They're born pregnant. So they're up and up already. Now you can shut them down if you want to. But normally when you create, it's like the 127.0.0.1 in desktop PC. It's always on. You can ping it as a test to make sure you put TCP/IP box. But you need something to write with? Hang loose. Let me see if I got something here. I got pencil. Okay, so let's check. I'm going to show IP interface brief. Notice the loopback port's up and up. I did not have to do no shutdown on it. So these ports are up and up, the 2 ports that we're going to use for this. Okay, now we're going to go to the second router, and we're going to give some IP addresses for him. So we're going to go to the configuration mode and say interface gigabit 0/1, not 001. Give him an appropriate IP address, and he's got 10.53. What is it? 0.2. First router was 0.1. I think I already did no shutdown, but I'll do it again just in case. Then we're going to interface loopback 1, and he's supposed to be an address of 192.168.1.1. Is that right? Yeah. So that gives us a couple of fake networks that we can test to ping to. So you recognize those numbers: 192.168 network. That's a private inside network. Probably your home router's got that address. 172.16. That's the so-called Class B private inside network. That's what our Wi-Fi devices here use 172.16. Our desktop computers here on campus use the 10 private address. So 10, 172, and 192 are reserved for inside, and you would normally do network address translation to the outside world with those addresses. Just like your ISP that you subscribe to, will change your 192.168 into whatever global unique address, one address that you get from your service provider. So at home, most of you guys are on cable. I'm on the phone company. So my outside address, if you could ping my workstation, ping my network, it would be 199.99.99. something is the physical global unique address that I have in the outside world from Southwestern Bell, AT&T, whatever they're called this week. Okay, so we have let's just check here. I'm going to do something that's not in the procedure. I want to just check and make sure that I have IP connectivity. So I'll do show protocol. I like this command because it shows you, like show IP interface brief, but it also shows you the slash number. Show IP interface brief does not show you the slash number of subnet mask. So I can see that I'm 10.53.01/24. I can see my loopback 172.16.11/24. I ought to be able to ping at this point the 10.53.0.2. Work. The first one failed. Always the first one typically would fail because the ARP resolution process took it a second to line up the layer 2 MAC address with a layer 3 IP address. And that usually fails. And if I do succeeding pings, ARP is held in memory for about 3 minutes, so it won't go away till that. So I got good connectivity between the 2 devices, between the 2 routers. Just for fun, let's look at the routing table. My directly connected routes are loaded in the routing table. I have connectivity to R2. I cannot ping the loopback port on R2. He's 192.168.1.1, wasn't he? I cannot ping him. Why? Well, they only do what you tell them to, not what you meant them to. So if we look at the routing table for R1, there is no entry of any kind for 192.168. He has no way to deliver the packet, so he drops it. The thing's fail. We're going to create a default static route for it and use OSPF to propagate it later. Okay, we're ready to do step B in the bottom third of page 4 of the lab, and we're going to start the OSPF process. And he's having us use a weird process ID of 56. It doesn't matter what the process ID is locally significant only. I'll go to the global configuration mode, and I'll say router OSPF 56. And I'm supposed to do the same thing on the other router. So config terminal, router OSPF 56. Did that come up right? We're going to give them a router ID. We talked about it in the lecture. There's 3 ways for the router to come up with a unique router ID, and it better be unique, or they will not participate with the other routers. Okay. The preferred common method now, the preferred method, best practice is to use this router ID command. If no router ID command has been typed in, then he will look for loopback ports, and he will use the highest numbered loopback port as the router ID. If no router ID has been configured and no loopback port has been configured, he will use the highest physical IP address of the real physical ports. Not a good practice because physical ports can go down, wires can come loose. So we're going to use the router ID command. 10 years ago in Cisco, Sarah, maybe you remember, 10 years ago, we used the router ID for OSPF. I mean, we used the loopback port for OSPF for the router ID. But they've changed their minds on that. Okay, so I'm going to specify router ID. Router ID is supposed to be 1.1.1.1 for number 1 router. The router ID is supposed to be 2.2.2.2 for the second router. Now we establish a router ID. Now, next of all, we need to bind the interfaces on the router to the router OSPF process, so they'll start sending out hello packets and looking for neighbors and establishing the adjacency and eventually getting up to the full state or the two-way state where they've calculated all the routing tables and put them in there. So he's going to have us do most of the networks in here. I'm at the very last step, little d on the bottom of page 4, and I'm going to be on router R1, and I'm going to give it a network statement of 10.53.0.0, which is the network that contains 10.53.0.1 and .2. This is the point-to-point link between R1 and R2. And now, oh, I told you guys in the lecture, you're supposed to enter the 0.0.0.255. I said, let's test this with our real machine. I'm not going to type the wildcard mask. I'm going to type the real subnet mask, and let's see if he fixes it for me. If he says that's not perfect. Some of the older IRSs would fix it for you. He took it. Oh, good. But now, what happens when I do a show run? As we say in East Texas, he gussied it up for me. Let's go down to the routers. He changed my 10.53.0.0 from 255.255.2.0 to the proper form, 0.0.0.255, the mirror image, the reverse of the subnet mask has been changed into the wildcard mask. And we'll get more wildcard masks later on in another chapter where we do access control lists, which you have to do exactly. He won't tolerate it in that one. Okay, so I've done R1, and now I'm going to do the same thing on R2. And they should start establishing adjacencies to each other. We'll see a little message pop up on the screen. So a network is going to be 10.53.0.0, and I'll type this one correctly, 0.0.0.255, area 0. Now the area 0 on both routers must match exactly, or they will not establish an adjacency to each other. Multi-area OSPF is now beyond the scope of CCNA. It has been moved to CCNP. The more complicated network, like Trinity River is area 0, South Campus is area 1. We want to isolate any inconsistencies or any problems in one area from another area, and to summarize the networks as they go from one area to the other. So we're going to make everything area 0 here because we want them to establish everything with each other. Pow, pow, look at that, wow. Oh, with the full state. Two-way state, went through the states of hello packets, and they went through the states of sending their databases to each other, the network databases with each other. And now we can look in our routing table, and we should be able to see, let's see, show IP route on this one, show IP route. I know there's no O's yet. That's because we haven't bound the other loopback ports to it yet. He's going to have us do one of them, I think, and not the other one. Here we go. It's in the next statement. So we're going to go to R2. I'm going to use the first option of the command. Thank you. Just any place with a chair and no X. And we're in the process of recording the lab walkthrough, and then I'll help you guys get going on the real lab. There used to be an objective for CCNA about configuring IP version 6 for OSPF. That's been moved back into CCNP. We just have to do, and there's no multi-area. So that's all been moved at CCNP level. We just have to worry about IP version 4, single area OSPF. No more RIP, no more EIGRP. That's all been taken out. When they did the revisions about a year and a half ago, they essentially took 100% of the objectives that used to be in CCNP, and they reduced it to about 75%. That's why the textbooks now have 25% fewer pages. That's why we're revising the Cisco Networking Academy to be 3 courses instead of 4 courses. So we are here in the capstone course now. Okay, so I'm going to type that command, and that's going to be, I should be R1, right? R1? No, R2. I'm not doing the wrong one. Okay. Oh, yeah, R2 is the one with 192.168. Okay, so I got to get back to the global configuration mode, and I got to get back to the router OSPF. Was it 56? Is it 56? It'll be the right area. By the process number, it won't work. Yeah, 56. Okay, now let's put in our network, our loopback network. And it's going to be network 192.168.0.0. And the inverse mirror image is 0.0.0.255. The subnet mask, area 0. Okay, now, since I'm now advertising that network up, how can I tell if I'm advertising it? Show IP protocols. I'm advertising the 10.53 network, which is the point-to-point network between R1 and R2, and I'm advertising that loopback port, which could be a real network or PC or something like that. They're both being advertised. So now when I go back and repeat the show route command, it's not showing up. It may take a second for it to show up. Let's just test it this way. Ping 192.168.1.1. No connectivity. Okay, little step F. We're going to check the show IP OSPF neighbor command. This is a little bit like show CDP neighbor. It lets you to see the OSPF routers that your router has established adjacencies with. So show IP OSPF neighbor. Oops, ambiguous. I can see that my neighbor is 2.2.2. Remember, R1 is 1.1.1.1. This is identification. Router 2 is 2.2.2.2. This is router ID identification. So I can see my neighbor, and I've established a neighborship with them. If I did show CDP neighbor, I don't see him because there's two switches in the way. Show CDP neighbors only shows directly attached neighbors. If we replace the two switches with a wire, it would do this. Okay, now I'm going to show you another command he's going to use later. This command is cool because it tells you that my neighbor is the backup domain, the backup router. Not the domain router, but the backup domain controller router. Okay, so I can sort of infer that I should be the domain, the domain router from that. So I'm going to do show IP OSPF interface gigabit 0/1. And this one tells me, oh yeah, I'm the backup router. Tells me what the backup router is, 2222. The designated router 1111, that's me. So I can see both of those in this report. I can't see that from show IP OSPF. Show IP OSPF interface shows us some more information. So which router is the DR and which router is the BDR? Let's go to the show IP OSPF neighbor. This router is not the full. This is not the designated router. His neighbor is a designated router. So by default, he's got to be the backup designated router. Show IP OSPF neighbor. This is the 1111 router. His neighbor is 2222. His neighbor is the backup designated router. So let's go back to R1 and type. I could type show IP route. He says show IP route. Oh, and something's wrong here because it's not showing up the OSPF route. Did I mistype a area number or something? Let me check my configuration. Hang loose. Show run. So router 10.53.00.0.0.255. That's proper. Let's check this one. Show running configuration. Okay, 10.53. Oh, 192.160. That's correct. This is the one with 192.160.1.0, isn't it? Show IP protocol. Let's type a network address 192.168. That's proper. 10.53 proper. 10.53. 10.53. Okay, so Let's just press on as if everything was going okay. Okay, now you remember how the designated router was elected? The highest router ID. If there were no router IDs, it was the highest loopback port. No, there's only one designated router. It's like there's only one president, there's only one vice president. Like elections, we can rig the election. So if it's like when we did spanning tree protocol, you don't want that little $500 branch office access switch to be the root bridge. You want the $50,000 heavy duty rack mount switch to be the root bridge, because it's having to do extra work to figure the topology. So with OSPF, we might want to make our $750,000 Cisco 7,500 router be the designated router, and not some little bitty $1,000 branch office router like we got in here. So we can change that, and that's what they're doing in the next part of the scheme here. So I'm going to do part 3, and we're going to configure port G001, and our routers is G01 to be 50 to make sure it's the average, it's the designated router. So I'm going to go to R1. Am I right? R1 here, R1. Okay, and we're going to go to the configuration mode, and we're going to go to interface gigabit 0/1, not 0001. It's a numbering scheme on the newer routers. And we're going to go IP OSPF priority of 50. Default priority 1, priority 0, never even become a designated router. We can make it any number we want to. So we're going to make it 50. And we're also going to mess with the timers. In messing with the timers, we are going to make the adjacency go down. Two routers will not maintain an adjacency if the OSPF timers are different from each other. By default, they're 10 and 40. 10 seconds every hello, every 10 seconds. 40 seconds, if I don't hear hello timer for 40 seconds, I declare my neighbor dead, and I can't connect to him anymore. So we're going to change hello, but we're still at the IF. So I can say IP OSPF hello interval of 30. I don't specifically do the dead interval. It will make it 4 times that.
Actually, you say that the default is 40.
So the default is 10 for fast Ethernet links and 40 for slow serial links. Okay. Most of the serial stuff's been taken out of CCNA. None of the labs have serial ports in them anymore. Remember all the S00, S001 stuff? Yeah, we're not going to use that anymore. No more point-to-point protocol. Been taken out. Some of that stuff's been taken out. Okay, now I'm going to go to router.
The hello, you put it by yourself. Whatever you want.
Sorry?
Put it by yourself. The machine gave you that by default. You put it by yourself.
No, by default, it's going to be 10 seconds. If you don't change, and there's usually at the CCNA level, you shouldn't mess with timers. Because if you don't change the timers and make them match on all of the other routers in your company, what if you have 300 of them? Then you'll lose connectivity. So I'm going to do the second one. Now, look, they lost adjacencies with each other. The dead timer expired, and all the time I was sitting here jabbering, 40 seconds left, goodbye, and they've lost their adjacencies with each other.
So you put hello interval for 30, so that's going to give you 30 seconds.
30-second hello interval, and that means the default dead interval is 120, 4 times 30. I only went to public school, but I think 30 times 4 is 100. Okay, so I'm now going to go to, let me do this here. Yeah, I'm still at okay, interface, gigabit 0/1, IP OSPF. Was it interval? Hello interval 30. They both match. And it may take a second for them to maintain the adjacency again. We're going to get this thing pop up on the screen in just a second. Now we're going to go, while we're waiting for him, we're going to go establish this default route. There we go. He went back to full. Now the hello timer's matched. EIGRP is no longer in the CCNA objectives. However, EIGRP also uses hello timers. But EIGRP's got a couple of weird things. This is a Cisco proprietary routing protocol. It does some weird things that nobody else can do. You can have unequal load cost balancing. Everybody else requires all the load balancing links to be the same. You can change the hello timers on one EIGRP router, and the other one will still get the adjacencies the same. You can change that. But we don't have to worry about that anymore. That's the CCNP advanced routing now. Okay, I'm going to establish a default route on R1. Right now, if I do a show IP route, gateway of last resort has not been set. There's no default route. In most businesses today, we're going to use some sort of internal routing protocol, OSPF, ERGRP, RIP, whatever we're using, because static routes are just hard to keep up with. Manual updates, too much chance of you doing typing errors. We'll let a computer automate it for us. You will use OSPF, and we'll let him make sure all the routing tables are updated properly every 10 seconds or whatever. However, we still need connectivity to the outside world. We probably have internet connectivity to talk to our business and trading partners and customers. We don't want the 750,000 routes on the backbone of the internet to be in our little $1,000 branch office routers. They don't have the capability for it. So what we're going to do is establish a default route. Just like your home, your $20 home router doesn't have the processing power to handle 1 million internet routes. Processing power is found at your ISP's $1 million routers. They have the guts to do that stuff. So I'm going to establish a default route. Any company's going to have a few dozen internal routes, like I said, this junior college district. And then we're going to establish a default route to our ISP, which is used to be AT&T, now CenturyLink, which is terrible. CenturyLink is a terrible provider. They go down all the time. Look up CenturyLink and see what's going on. So I'm going to establish the route, go to the configuration mode, and IP route 0.0.0.0, which means any network that is not found in the routing table, more specifically with minimum 24 bits or whatever, normally would be dropped. So 0.0.0.0, any network, any subnet mask. Just didn't type that right. What's the exit interface? Let's see, it's given to be, lost my place here. Loopback 1. They misspelled loopback in the print. And he warns you that if it's not a point-to-point network, this is just Cisco and Nines thing. Yes, sir. Pardon? Oh, show IP OSPF topology. I'll show you the topology table.
So you don't have like a little map or like a topology?
It's on the, it's in the lab, which is go to my TCC Blackboard and pick this lab and print it out for today and then turn it in, do the lab report. Let me get through this recording and then I'll help you do that. You meant this topology. It's the two routers with two switches in the middle, and the switches in the middle merely pass through. There's no VLANs, there's no management addresses, nothing on. No virtual machines or nothing in this lab. Okay, I've established the default route on this one, because if I type show IP route, the gateway of last resort has been set to that doesn't look right. But when we look at the other one, show IP route, it still has no. So if you're attached to R2, you have no connectivity to the internet. Let me go back and check that code I typed in there. I'm not sure they did that correctly. This doesn't look proper to me. Show run, and let's look at the static route. Okay, IP route 0.0.0.0.0.0.0. Loop back 1. I did say loop back 1. Well, I'll follow those instructions. There may be an error in the lab. Config T. And now we're going to go into the router OSPF 56 function and go back to the config-router. And what we're going to do, instead of running the 300 other routers and repeating IP route 0.0.0.0 and figure what's the next hop IP address from this router to get to the internet, we're going to use OSPF routing protocols, send network information to all the other routers, don't they? Let's have them send, as well as all the directly connected networks, let's have them send this default route to all the others as well. So I'm going to give the command default information originate. That's going to cause R1, which has got the serial point-to-point linker, the Metropolitan Ethernet link or whatever to our real-world ISP connection. That will send it to all the other routers. If this lab was written properly, I've already found one typographical error in here. We'll just show IP route. propagated did okay. So on this one, I'll show you the difference here between the two of them. There's a slight difference. Here's the router that actually is connected to the internet service provider. S star static default route 0000. All networks that are specifically in the company must be internet. Send it to the internet address. So on this one, it's the same values, but it doesn't say S star. It says O star EX2. It's the default static route that was propagated by OSPF to all the other routers. It's called TAP2 external route. It's technical, but that's the way it prints out on the table. So try not to worry about it. Okay, now on R2 only, we're supposed to add a step here. The OSPF to treat R2 loopback 1 like a point-to-point network. So in the config T interface loopback, I think it was 1. And IP OSPF network point. Put it. This is normally in the 10 years ago and previously, all point-to-point networks were serial links, like a T1 line or frame relay line. These days, all serial link is gone. That's why we decided to get rid of all the serial stuff. So Ethernet is a multi-access network, which means many things can be connected. We have connected the two routers through point-to-point through switches. We could have done it with a single Ethernet cable. So when we tell the configuration it's a point-to-point network, that tells them, oh, you don't have to worry about multicasting it to a bunch of other routers or things like that. It should clean it up and make it more efficient. Okay, now it should do little step E on the second router. So router, back to config T, router OSPF 56. Did that correctly? And passive interface, I didn't talk about this. It wasn't in the slide, oh no. It's passive interface. If you have an Ethernet port that's not connected to any other routers but goes to a room full of employees or students, they don't need to listen to hellos. They will never participate in the process. So we can take a network and say passive interface it, passivate it, ES it. It's still being advertised to all the other routers, but we won't waste any hello packets, slowing down that network slightly. So that's what I'm doing here. Now, I could just not advertise the network, not put in the network statement for it, but then that network full of employees or students would never be advertised to the rest of the topology and they would not have no connectivity. So this is the way to do this. Okay, step F, we're going to change the reference bandwidth. This again is something that the CCNA, you normally wouldn't mess with this because Cisco routers are very good at figuring out the bandwidths by themselves. Maybe you bought a company and they have some other brand of router. And so you have to manually adjust the cost to match what theirs is. Maybe it's a Lucent or Notel or Send or some other brand of router that doesn't quite match up what all the Cisco routers are consistent with each other. Okay, I'm still at the OSPF. Did the passive interface. Oh, I'm still at the router prompt. Okay, auto cost reference bandwidth. It's 1,000. Okay, so I was warning you. This has to be consistent across all the routers, or you could get weird results. Because if one router and another router don't agree on costs, they might not choose the most optimum path. So he's going to have us do the same thing on router R1. I did it on R2 first. I did it out of order. Okay, so config T, router OSPF 56, auto cost, reference bandwidth, and it was 1,000. Should match the same on both of them. Okay, now we changed stuff. We have changed who the designated router should be. We have changed the reference bandwidths. Now I could do copy, run, start, and reload both the routers. And we could wait for 4 minutes, which is about as exciting as watching grass grow or as watching paint dry while they boot up again. There's a process here. It's given at the page. It's not in bold type for some reason. But we're going to type that command on both the routers. So I'm going to go to clear IP OSPF processes. It warns me. I'll do it on the second one and do it at the same time for both of them. Clear IP OSPF processes. The default's no, but we're going to say yeah, yes. This is a little faster than, oops, oops. There we go. So they went through the process. They detached from their neighbors. They reset cost figures. And now there's going to be a brand new election for the designated router and the backup designated router. And we have forced it to be the one we wanted it to be. So I'm at the top of page 7 now, and we're going to check and do some show interface command. He's finally doing that here now. Show IP OSPF interface G0/1, not G001. I'll do it on the other one too. Show IP OSPF interface G0/1. So the designated router is now 2222, and the backup designated router is 1111. And that's the slight advantage that this command has over show IP OSPF neighbor. Neighbor just tells you what your neighbor is, and you can't figure out, it doesn't tell you what you are yourself. This one shows you the whole thing. Now on R1, we're supposed to show the routing table, show IP route. I'll just tell us to the whole thing. And then on R2, show IP route. We've got the default static route has been propagated, okay. But this proves that our OSPF is communicating back and forth. I still have like a previous issue, but it's not propagating the 172.16 properly. Okay, I've stepped through the whole lab. Hang loose here. I'm going to stop the recording, and then I'm going to get you guys going on the getting connected and printing the lab and so forth. Stop recording.